We are once again modeling real-world systems, and this time we're doing something called constraints with systems. That means we're going to put limits on whether something can have certain inputs or not. So if we just read through this with us, a real-world situation can often be modeled by a system of equations. Usually the information about prices and total number of items is given, and the system is solved to find the number of items purchased, right? We've been doing that, all right? So for instance, Joe goes to the store to buy jeans and some t-shirts. He's going to buy jeans and some t-shirts. We got two variables there. Jeans cost $40 each. T-shirts cost $20 each. Joe spends $160 on 5 items. How many pairs of jeans and how many pairs of t-shirts did he buy? Well, we can write an expression for that, right? Jeans, I think, were $40 each, so we'll say 40x. They want us to use x. Expression arrangement. T-shirts, they said were 20, and they want us to use y. All right, so we'll say 20y. And then we have an equation that says 20x. Oh, take that back. 40x plus 20y was equal to his total amount, which is 160. I hope these are kind of getting easy now. What variable represented the number of jeans purchased? Well, we've got x. How about the number of shirts right there? Jeans and shirts, we've got y. Write an equation to represent the total number of items purchased, which I think we did already. But we'll do it again. All right, you've got 40x plus 20y equals 160. All right, which apparently I'm going to write here again. 40x plus 20y equals 160. And then, you know what we can do? We can divide that by 20. Look, 20 goes into everything. So if I divide this by 20 and this by 20, we just get x plus y equals 5. Right? That's a nice equation. What units are associated with two expressions that you wrote in steps A and B? Expression means up here, right? There's no equal sign. That's what makes an expression. And, well, what units? We are talking about the number of items bought and their cost, right? So this would be 40x, and 20y would be the cost and number of, in this case, jeans, and 20y would be the cost. I should put a T on cost. And number of shirts. When you add the units for an expression representing the amount spent on jeans and t-shirt, what units do you get for the total amount spent? Well, we are talking about dollars for the total amount spent. All right, there's a page. Let's keep going. I'm sure we're going to explore this again. All right, we're seeing this actually. This is a sample problem, and I'm going to let you look through that because, you know, every time they do a sample problem, we get one of our own. So let's go ahead and look through this and do this. All right. So we've got a problem here to do. And it says a student is buying pens and markers for school. Pens cost $2.75, and packs of markers cost $3.25. We're talking about packs, I guess, for both. Right? If she bought 6 packs and spent $17.50, how much did she buy? Well, let's talk about it. Pens, right here, were $2.75. Look, a little graphic organizer, right? Per pack, we'll say P, right? And markers were $3.25 per marker pack. So we got P and M here. And I think she said we bought 6 total packs for $17.50. So we can see this one right here. Do you see this? It's talking about the total amount spent. So this would be $2.75 per pack and $3.25 per pack of markers. And then the total amount, just the amount of packages bought, we know is 6, which leads me back to just really quick. This wasn't divided by 20. I'm feeling a little guilty. So I'm going to erase that right there, here. This wasn't divided by 20. That was just the number of items bought. little more early in the morning, I think I made a mistake on that first one. Just like this right here is the number of items bought. So if I multiply the second equation, if I multiply everything here, so we're going for elimination where you add things up by, I don't know, let's multiply it by negative 2.75. And then we'll get our packs to cancel out, right? So that would be negative 2.75 times all of this equation times this equation here, right? If we do this, we get negative 2.75 per pack of pens and negative 2.7575 per pack of markers equals negative 16.50. I'm just going to say what we did again. We took the second equation and wanting to cancel out our pens, we multiplied by negative 2.75. So the first equation was once again 2.75 pens plus 3.25 markers. $3.25 per marker was $17.50. That's our first equation. And now our new changed equation, right, was negative 2.75 pens and negative 2.75 markers equals negative 16.5. And then when we add those together, well, that's half a marker, 0.5 equals $1. Well, if 0.5 equals $1, a full marker is $2, right? Now, what if I plug all that back into the first question? I'm sorry, 0.5 markers is 1. This isn't dollars anymore. This is a number, right? So 2 total markers. All right, so if I plug that back in, so I come down and I've got this P plus M was 6. I plug in 2 for markers. That means the number of pen packages was 4. So the student bought 4 packages of pens and 2 packages of marker. What's another way to solve the problem? Well, we solved with elimination. We could use substitution, right? Hopefully these terms are getting a little easier. That means we'd solve for P or M and substitute into second equation. So I'm not sure how much time we've got on here. It's probably a pretty long one, but let's go ahead and get this next one too. All right. So it says write a system of equations to represent the situation. All right. The company has to buy computers and printers. Each computer is $550. Each printer is $390. Company spends $8,160 for 16 machines. All right. So let's just make computers X and printers Y. I'm going to start off with 16 machines. I know X plus Y equals 16. And then let's talk about the value of those machines. So we'll say 550 per X plus 390 per Y is equal to that 8,160. All right, so we've got 2 equations. All right. Let's go ahead and multiply this equation over here by, I don't know, negative 550. I'll make my computers cancel out. Negative 550. And we're going to write it here and then add them up. So we've got negative 550x minus 550y. And then we got negative 550 times 16, which is negative 8800. All right. When I add those together, all right, that's 550, 390, that gives me negative 160y is equal to, what is that, negative 640, and then you know we divide by negative 160, and we get y equals 4, so there's 4 printers. Now what we're going to do is we're going to plug 4 printers back into that original easy equation, right? If I have to choose between this one or this one, I'm definitely going with this one. So we're going to say x plus 4 equals 16, or x equals 12. I'm going to circle it. So company, bought, purchased always sounds like a better word, but we'll use bought 12 computers and 4 printers. I'm going to pause with that. We've done, I think, the first 4 pages because we're going to have another real-world inequality example down here, and it's a whole different subject. So we're almost there. I'm going to pause this and post it up.